All right, let's look at this cosine function and then let's see if we can draw some conclusions without even having to study what this function means. Well, the first thing we need to notice is that we have this basic cosine function. So a basic cosine function would always cross at 1. So this is the function right here at the bottom, where you have f of x is equal to cosine x. Now what you have to do in high school is, in high school you have to graph these functions, or the teacher might ask you in some exam, well, hey, here's a function 2 cosine x, places on some coordinate graph. So what we first need to know is, we can see that it goes up until this first point on my y-axis, right? We have this first point. And then the lowest point it reaches at -1. So we can see that we have an amplitude of 1. Now notice, this cosine function creates this little hole. It almost looks like a mountain, a perfect mountain, symmetrical at this point, meaning it's equally divided left and right. Okay, equally divided. Now what you'll notice is, as in my previous video about the sine functions, is that it has the same period points. Meaning, if I take a circle, now you can relate this back to the unit circle where you cut the unit circle into 4 pieces, the angles. And we can see that we start at 0 and we end at 2 pi with these 4 points. Well, you can do this by simply taking 2 pi and dividing it or multiplying it by 1/4, 2/4, 3/4, and 4/4. Okay? And what we can also do is, what we can notice is that, well, this is a circumference of a circle. Okay, so my basic cosine function is the circumference of a circle, and then you'll link this to the unit circle. Okay, well, sometimes these things might be negative, h and k, but in some textbooks it's c and d, depending on where you're studying in the world. So let's have a look. What happens here? Well, first things first, we're going to address this a. So if I clear this function, look, I clear it, so it's just a basic function. So we have an amplitude of 1, and we have this b of 1, but we don't know what this b is yet. Let's see if we can analyze what it is. Okay, so my full revolution is going to be 0 to 2 pi, which then means 2 pi to 4 pi, right? If I continue my oscillation. Okay, so you get the idea. Let's see what happens if we increase 1. Okay, so I'm going to play. We can see, if I change 1, we have this increase of amplitude, right? Look, it goes all the way to 10, and now all the way to -10. So now we have a negative shift. Okay, so I'm going to pause. And what we can see is, well, whatever a is, that will be my y-intercept for the start of my function. Now, as you've guessed, if it's +4 over here, where would the end result be? You can think about it as a symmetrical switch on my x-axis. So therefore, my lowest point has to then be -4. So we can now see, well, a affects my amplitude, which is the point of my axis to the highest point of my function. Okay? So in this case, it's going to be 4. Okay, a is covered. Easy stuff. Let's see what happens when we increase or decrease this b. Okay. Oh wow. We can now see, well, it affects the oscillation. So if I increase it to 10, I have a quicker oscillation, right? A quick one. And if I decrease it all the way to 0, of course at 0 I'll have no oscillation. So we'll just have a slope of 0. And in that case, there's no oscillation, so it's just pretty much a straight line. We can think about this when we multiply the 0 into my equation. So over here I have b, so b will multiply 0, 0, 0. And since k is nothing, that's also 0. So then we have the cosine of 0, which is then 1. So then we have 1 times cosine 1, which is just 1. So the f of x is 1. That means y is 1. So then this function represents y is 1. Okay. So now, we can see, well, if we increase this b, it increases my bumps, my mountain. Okay, so there's more little mountains in the way. Okay, so what does this mean? Well, this means the revolution of my circle is quicker. Look, now it's still 2 pi, but we have this new point, 9.1. Okay, so my x becomes smaller. Okay, my x value. So let's take it back to its original point, where we have 1. In this case, we have 1, and we have 1. The hell? Okay, never mind. Sorry about that. I was wondering why the hell that coordinate wasn't changing, because I was shocked now myself, considering that Desmos told me this was 2 pi and 9.1, when clearly that obviously cannot be the case. Okay, anyway, sorry about that. I think it was a technical error on Desmos. Okay, so now we have these 2 points. So my x now is 2 pi, and we have this point of 0 and 2 pi. So we can see we have a increase of our x. So from this point to that point, it's increasing. Now, if I change the oscillation, my x value becomes smaller. That means I have a quicker oscillation between my waves. And it doesn't even have a sound. We can even listen to it. So this is how it would sound. Hey, the hell wrong with it? Huh? Well, sorry about that one. It seems like my Desmos froze, which is interesting, since I have i9 11th gen, so I didn't think that should be happening. Anyway, I have no idea what happened. So let me go back to the sound. Let's see. Oh, it froze again. Oh, all right. Well, I'm not gonna try that one again. Okay, so let me take this back to 0. 0. Okay. So we've covered A and B. We know now that A increases the amplitude on my cosine function. Very important. Sine function crosses at the origin. Cosine functions crosses at the amplitude, my y-axis. So what happens when we touch this negative h? Let's see. Okay. Well, it seems now that I have the shift. The shift. Look, this is my original point, okay? This is the starting point I want. Look at them. All the way to the left. And when we decrease it, it goes all the way to the right. So when h is 0, when in this case it might be c sometimes, when c is 0, it crosses at the origin. But then we have this horizontal shift. Look. Gone. So if I increase it from 0, so if h is greater than 0, it positively increases on my horizontal axis, or on my x-axis. Okay, so it goes. But if I decrease it on my original point that I'm interested in, is shifting to the left on the x-axis. So that leaves us with one thing then, the final thing, where we have k. So what could k then be? If that was a horizontal shift, well, now we're left with a vertical shift. So I guess we can guess what happens. Look at my function. Now, you need to understand this, because we're going to have an increase in my amplitude now. Or it might appear that it's an increase of my amplitude, but it's not really. It's an increase of my function, because my amplitude will stay the same. So that's the tricky part. You need to be careful, because that's sometimes very tricky. That you might think, whoa. They'll give you this function where, let's say this is 3. Now they ask you, well, what's the amplitude? Now you might be tempted to say, well, it's 4. But no. My amplitude is still 1. But I have to create some asymptotes, right? So my new x-axis would be over here on the point 3. Since my amplitude is 1, I have a distance between 3 and 4, which is 1. So my new line will be something like this. Y is equal to 3. And then we have my new cosine function. So now we can see the height increased on my x-axis, but the amplitude did not increase. The amplitude is still the same. Look, an amplitude of 1 and negative 1. Okay, or 1 and 1, since amplitudes will be positive. Okay, so let me remove this one. Let's take y is equal to 4. Now I'm going to increase my vertical shift by 4. Look at that. Okay, that's the idea behind this k value. It's my vertical shift. Now, we can now know that, well, positive y is from 0 all the way to infinity. So if my k is negative, that means my function will definitely be below. It will be below the x-axis. Let's see. So let's take it to negative 1. So if it's negative 1, now it crosses through the origin. So we have the shift. Okay, we have the shift. So let's rerun through all these concepts quick. A is the increase of my amplitude. B is the increase of my oscillation, or the period. Okay, it decreases my x value when B increases. When B decreases, it decreases my value. Same thing, up until 0. And then we have a vice versa point. Okay. Now this also affects my local minimum and local maximum when you changes your A and B. But we'll get into that another time. H is responsible for my horizontal shift. And K is responsible for my vertical shift. Now the same principles apply to the cosine and sine function. Okay? The same principles. But what you should be very careful of, or not really careful of, but you should know it. Like if you see a bird outside flying, well, we know it's a bird, right? If I see a car outside, well, I know I can identify that thing by a car. So if you look at these two functions, you should be able, let's add tan as well. You should be able to identify these 3 separate functions. And you might not necessarily need it forever, but at least for your high school period, or I mean, depending if you're going to study engineering or calculus or economics, you know, you'll definitely need these ones. But for the high school period at least, you need to be very familiar with how these functions look. So I look at the function and I know, okay, that's a sine function. And the biggest problem with high school mathematics is that students cannot necessarily identify functions. And it makes your life so much easier, really. Look, so if I see this function by itself, it's just chilling, okay? It's relaxing on a coordinate plane. Well, now I know, well, look at that. It reaches 1. It seems like it has a period of 2 pi, or let's take this point, well, it's 6 point something. We know that pi is 3.17, and we can multiply that by 2, so it gives me 6 point something. So it's a cosine function. Well, look at that. And then I know it's an amplitude of 1 because it crosses at the 1. Next, I see this one. I see, whoa, some function that has an amplitude of 1 and it crosses at my origin. Well, I can, whoa, that's a cosine function. And then we have this weird, a sine function, excuse me. And then we have these weird little lines with the distance between them being pi, 2 pi, etc. Oh, so that must then be a tan function. And by understanding, by being able to identify these functions and identify the parameters that affect them, meaning if I change this value to 4, we have an increase of my amplitude. If I change this value to -2, we have a decrease, or I mean the amplitude is still the same, but we have a negative shift in my amplitude. And if I add some value here, it's going to shift upwards. But it doesn't affect my amplitude. Okay? And this is how you can, through practice on Desmos, this is definitely how you can get full marks for trigonometry, at least when it comes to functions, in my opinion. Or you can go learn it theoretically, whatever you choose to do. But let's say we're given some function now where we have the f of x is equal to 3 cosine 2x, and let's say we want to plus 4. Okay. Well, now we can see, well, I have an amplitude of 3, but my new starting point is 4. So what do? Well, I go to the f of x, or the y, where it's equal to 4. And from this point, I draw a little dashed line. Okay, a little dashed line. And from that point, I'm going to count 3 up. 1, 2, 3. I make a point. I'm going to count 3 down. 1, 2, 3. I'm going to connect another point. Okay, I got my amplitude up and down. What's the next one? Well, I have this 2. So now I have my formula where I can calculate to calculate the period. How do we do that? Well, we take 2 pi and we divide it by whatever's over here. So we can now see that the basic cosine function, let me go back to this one, because it's very important to make this connection. It makes trigonometry so easy, really. You have this point, this 1, and you have 2 pi. So how the hell did I get from 2 pi to 1 pi? The hell wrong with this thing? Well, what did I do? I divided. It seems like mathematically I just divided by 2. So now can we logically conclude a formula from that? Well, we can then say, if I see this value is 2 and this value affects my period or my oscillation, I can now say, well, it seems that it's 2 pi divided by 2, and I get pi. So we can take whatever value is here and we just divide it, and we can make these new points. And teachers wouldn't really be upset as long as your points are indicated, like this one. This one says pi 7. As long as your points are indicated, it doesn't really matter if they're directly on top of the axis, right? As long as you know what the points are, that's probably the most important thing. Anyway, back to my original point. Now you're asked to graph this function. So what you need to understand is the following. We have this amplitude, so it goes 3 up and 3 down. We find our period, and we know that the one at the end, this final one, we know it affects my vertical shift. So first things first, we go find our vertical shift, we draw a little line. Second thing, we calculate our period, we make dots. Third thing, we find our oscillation, and we draw this, or we find our amplitude, and we go connect the 2 points. And then you have 4 points, 1, 2, 3, and 4. You have these 4 points, and you can continue making your function forever. But all you want to do is you want to indicate it with some arrows, okay? Just some arrows to show the teacher that the function is continuous, so it does not end, because we have a domain which is how you can think about it as how far my function can stretch. So in this case, we have a domain that goes from negative infinity to positive infinity. So we just show with these arrows that they continue. And be careful, because if you don't make arrows and you end it at a point, it means it's a segment, which is not a line. Okay? Very careful. And if you have 1 point and 1 arrow, it shows it's a ray. A segment has an end at 2 points. A ray has an end at 1 point, but a line has no end, and we indicate that with 2 little arrows. Okay, so the idea is that you want to go down here, up there, and at this point you can just make a little hinge, and you can draw an arrow there, and you go down here and you draw a little arrow there, just to show the function's continuous. Okay, bye.